Okay, hello everyone. So to continue with our discussion, so let us go with the adding. Okay, so adding before or adding an empty list. Okay, so far we have discussed. Okay, when we add at the beginning, when we add at the end, when we add after a certain position, and add before a certain position. So now let's try and create a method or another method that would add whenever the initial list is empty. Actually, we have did add beginning. Okay, the add beginning is capable of doing that. Okay, but just in case if you want to have another method that would add uh, an item, okay, or a node whenever the initial list is empty. Okay, so it's quite short. Okay, so of course we need to define add, say add empty. So we have oh, two parameters here or one parameter for our data. So simply we would write if self dot head. Again, this means that if self dot head is equal to none, then our list is supposedly empty. Okay, so we could say new node is equal to node.data. So we create a new instance of that node. Then we assign the head value of that to the new node. So else, okay, let's say if the value of if it's not empty, then of course this method will not make sense. So we could write here, okay, there are contents in our items or in our list. So we'll write um, list is not empty. Okay, so that's it. So let's say uh, we're going to, so let's try commenting this out. Essentially, erasing the contents, okay, of our list. So we're going to run this. So we should be able to see this part here. Okay, display list is empty since our head is has no value. Okay, so we have commented some of this code. Okay, so as you can see here, this is empty. So at this state, you can make use of this statement here, this method here. So what you can do is let's say sll dot add empty, and we provide here the data. Let's say uh, 80. So once we display that, okay, so okay, so we're going to run this. As you get to see, it's now able to do so. If we're going to do this again, then this would, okay, say, okay, the second statement here after this would tell you that the list is not empty since at this point the head is already not none since we already have one item in our linked list. Going to run this. As you can see, list is not empty. Okay, still it shows here the current value, the current, okay, status of our linked list. So let's proceed with deleting. Okay, so let us uncomment this. So deleting at the beginning, remember what I've discussed during my introduction on this linked list is you need only to, okay, you need only to remove the reference of a certain node, okay, or you just make that node, there's no you just make it in a way that that node, there's no reference pointing to that node, okay. So when there's no reference, or when it's referencing nothing, or we don't have, let's say, there's nothing to point towards to this node, okay, then Python, as part of its garbage collection, okay, when there are uh, references that no pointer points to, okay, so this would be removed from the memory, or it would be freed from the memory. Okay, so what we need to do is, let's say, okay, if you want to add a delete at the beginning, okay, you simply need to change. You made it the way that this is no longer being referred to as the head, but the second item here. So you want that this, okay, you want this, so you want this to be pointing here. Okay, so our head should be pointing here. So instead of pointing to 1,500, okay, it should be pointing to 1,100. So once that is the case, okay, so this would be freed. Okay, okay. So in order for us to do that, the code is quite straightforward. So you would write def define or delete beginning. Okay, so of course, if it's empty, we should not do so. If head is equal to none, okay, print list is empty. Okay, else or takto. Else self dot head is equal to self dot head. So the current self dot head, okay. Originally, our okay, before removing this head, okay, this node points to this. Now we want this node to point to this. You'll see we only need to, okay, get the reference of the current head. Okay, so what you're going to do is self.head.ref. Okay, so that's it. So if you're going to try, okay, so if you're going to display this, so we still haven't deleted anything. Okay, so still, okay, this is still the case. This is our head. Okay, so this followed by this, then 70, 20, 60, 30, 50. So we want to remove 40. So what we can do is, okay, we call this SLL dot delete beginning, okay, like that. So we're going to run this. What it will do is, it's going to perform this step here, okay. Since this is not none, so it's going to perform this step. We're going to run this. As I can see, 40 is no longer there. Okay, so that's deleting at the beginning. So deleting at the end, okay, so let's say we remove this. Okay, so now this is the current state of our linked list. So deleting at the head, again, we always make sure that we are not deleting. Okay, delete and okay. So there are two things that we need to take into consideration. Okay. So there are three things you need to consider. Okay. First is again, you make sure that it's not empty. Another is if that is the only node in your if that is the only node in your list, or there are only one item in your list, and another is if there are multiple items. Okay, so you already know what to do if the initial list is empty. Okay, so we print here, we tell the user that the list is empty. So how about, okay, if, okay, how do we know if there is only one item in our list? So we know that if, okay, diba? There's only one item in the list. Essentially, let's say this points to this, okay? That last item would always have a reference of none. Okay, so there's no other node in this list, okay, that has a reference of none unless it is the last node. So you could simply write if self dot head dot ref. Okay, so if the reference of this head node, okay, if this is none, essentially telling us that that is the first and last item in that list. So if that is equal to none, what should we do? Okay, we simply set the head to none. Diba? We essentially deleted that last remaining that last remaining node. Okay, so self dot head is equal to none. Then finally, for let's say if there are items and it's not the last item, so again we'll have this. We're going to iterate. Okay, so we're going to iterate the same as what we did when we want to add at the end. Okay, we want to iterate at the part. Okay, we want to iterate at the second to the last part. Okay, di ba? We want to remove this node. In order for us to remove this node, we need to find a way that this is no longer being referred to, or there's no reference to this node. So essentially, what we can do is we need to go to the node before this node that we want to delete, then we set this to none. Doing so, okay, if we do it like this, okay, we are essentially freeing this node out from the memory. Okay, so how are we going to do that? Simply write, okay, we simply need to traverse, okay, we already know how to traverse through a node. So while n, okay, so while n dot ref, okay, dot ref is not equal to none, okay, what does this do? Okay, n is, let's say, at the first iteration, okay, this is our n, okay, this is our ref, okay, so n dot ref, okay, so this essentially points to this node here. Okay? Diba? So as you can see, this points to 1800, okay? In this part here. Okay? So and that ref which points to here, okay? That ref, okay, you see how it accessed it. So and that ref, so it points here. Okay? So the reference of that reference, okay, is this point here. While that is not equal to none, okay, it would stay on that iteration, or it would stay on that value of n. Okay? So as you can see, if it could, okay, if it iterates, then it gets to see that essentially the reference of the next reference, okay, that is this is what this is what it will do. Okay, it would check the reference, okay, of the next reference, okay, if it's none. If that is the case, then it would stop iterating. Okay, then okay, if it is none, I mean, okay, so if it is none, then it will stop iterating. But as long as it is not none, okay, it would, okay, it will continue to iterate until, okay, so what this will do is, okay, so first iteration, refer to this, okay, it's going to check the reference here. If it's still not none, it will go to here, okay, then check its next reference. It will go to here, then until when our pointer, okay, or when we iterate into this part, okay, upon checking here, it's already none. So this would become true. Okay, so we will now, okay, use this as our node. Okay, we're going to modify this node to be our uh, last node. Okay, essentially we are going to change this to none. So, okay, so we already know this part. Okay, this is the traversion part. So if it's true, this is if this is no longer true, then we move outside that. Okay, we move outside that loop, then we simply change the reference of that current iteration of n, okay, to none. So that's it. So if you're going to, okay, if you're going to run this, okay, just as a recap, okay, so this is our value of our linked list, okay. So when we are going to write here SLL dot delete, okay, and so we expect that this 50 would no longer be there. We're going to save this and run, okay. How do I run this? Run control. Okay, so as you can see, 50 is no longer present in our list. Okay, so the last method that we're going to do is deleting by value. Okay, so let's say we want to delete a certain, okay, node, okay, by value. Okay, we want to specify what value what node. Okay, remember when we're going to run this, okay, we could only see the data or we could only see the value. Okay, so we want, let's say I want to delete 60. Okay, so that would be the value that you are referring to. So we could write, okay, define delete by value, okay, self, okay. Okay, so again, there are things that you need to consider. Okay, so first, if the list is empty, okay, so if self dot head is equal to none, okay, print list is empty. Okay, so if that is the case, then we're going to return. We could not really delete something that is not non-existent. Okay, so we are going to return that function. Okay, we preemptively end the function by returning it. So if x, okay, if it is the same with our head, okay, so let's say if the value of x is the same as our head, what we're going to do is we are going to assign our head to self dot head dot reference. Okay, so it's like the same with deleting at the okay, deleting at the beginning. Okay, you'll notice it's just the same. It's since it's possible that the item that you want to delete as is at the okay is at the first or it's the head of our linked list. Okay, turn that. If okay, so if now for the rest, okay, so for the rest of our okay, uh, for the rest of our use case, okay, again we need to check if the uh, same with add before and add after, in which we want to have the value of x, so the position. Okay, we want to know the position if it exists or not, di ba? Remember, there are two things you need to. There are two scenarios. Okay, the scenario is as you traverse your list, you get to find the item. If not, then okay, there's that item does not exist, so you need to find you need to tell the user that that item does not exist, so it would not perform such operation. Okay, so okay, first is we need to traverse. Okay, and it's equals to self dot head, while n dot ref is not equal to none. We already uh we already know that. Okay, so as long as our reference is not equal to none. Okay, if n dot ref dot data. Okay, if n.ref dot data is equal to x, meaning you while you were iterating this, okay, and let's say there is a matching data in any of this node, okay, to whatever value that you have specified, then okay, what we need to do is break. Okay, we move outside of this loop. Okay, then we use that n, the current iteration of our n, to check if, okay, if we did, in this case, di ba, if we encounter this, okay, then it would break, then we now have a node that exists, okay, based on this value. Okay, so if not, so essentially, this would keep on traversing, okay, so this would keep on traversing. If it traverses and it doesn't encounter this, so essentially it would arrive in a situation in which the n.ref would be none. Okay, so we need to check. Okay, so if n.ref is equal to none, meaning we have traversed successfully or across all items in our list, but we still didn't encounter this, so we'll tell or we'll print here, okay, item not found. Else, okay, if there is, okay, if we encounter this scenario where the value of x is present as a data in any of our node here, okay, again, I might not have reiterated this, but we are referring to n.ref.data. Okay, so let's say n.ref, so in this case, oops, dot data. So earlier we have used n.ref.ref. Okay, now we use n.ref.data. Okay, so while say so let's try and traverse this. Okay, let's try and understand what this will do. But for that, let us finish this step here. Okay, so this is traversion, okay? While this is not none, meaning we still haven't moved to our uh, last node, okay? It's going to check, okay? If n, okay? So n dot ref, okay? Dot data. So it essentially check, okay? If, okay? If that value is the same with what we have specified, okay? So it's going to do so. It's going to compare that. It's going to check if it exists. Okay. So until the value of our n, of our reference of our n here, okay, until it arrives at this point, okay. So this is the two situation. If the reference is none, or n that ref is none, so we have traversed in our list and we haven't found that item. Or if we do find that item, so if we define find that item, so what we're going to do is that current, okay, uh, the current value of nref. Okay, let's say we want to delete 30. Okay, so we want to delete the second to the last. Okay, so if it gets to encounter that, okay, so this should be n. What it would do is n dot ref here. Okay, we want, diba? We want this reference. Okay, we want this node. Since we want to delete this, okay, we want this node to be referring to here. Okay, so we need to change the reference of this to be pointing here. Now, where could we find that reference? Okay, that reference could actually be found in, okay, the node after this, okay, and its reference. Okay, diba? So we want this to be stored here. Okay, so we want this to be stored here. So essentially pointing that there. So we need to change this to like that. So since there's no reference or there's no reference to this node, so this would be freed. Okay, so this would be deleted. So now we have this new list. Okay, so now we have. So if we're going to run this, okay, we still haven't do so. We still haven't deleted a certain list, a node. Okay, if we're going to run this, you'll still see. Okay, 10, 70, 20, 60, and I have deleted that, but originally there is there. No. Have I delete at the end? Okay. So since I have issued this statement, uh, this is no longer the case. But let us so if we delete at the to remove this, okay, I think we should be able to. Okay. So 50 was not there since we have written the delete end earlier. Okay. So let's say uh, we're going to delete 30. So we want, okay, that after 60 is 50. If we're going to, okay, remember, how we're going to do that, we need to find a way to this node, okay, to refer here so that this would be released from the memory. Okay, so the reference of this node would now then be pointing to here. Then I'm going to delete that. We'll delete this here. Okay, so we should arrive in a list where we have 10, 70, 20, 60, and 50. So if we're going to run this SLL dot uh, delete, okay, delete by value, delete by value 30. Okay, Going to run this. As I get to see, 30 is no longer there. Okay, so that's it for all the methods. Okay, of course, there are still more methods that you can do. Okay, but I will end my discussion here. Hopefully, you get to have an idea how linked list works. Okay, so, so if we're going to, let's say, we're going to put all of the methods that we have tried here. So delete and let's say we want to delete. Okay, if we're going to do it like this, okay, let's see what will happen. Okay, okay. So hopefully you get to have an idea on how this works. Okay, hopefully you will try this out. Okay, understand what has been done. Really, it's very straightforward. As long as you get to understand how you should do things here. Okay, it would be readily understandable here in our code. Okay, so that ends our discussion with linked list. So,